Welcome to the Explainer. Today, we are literally rewriting the rulebook on why you feel hungry. For decades, we've thought of human appetite in these incredibly simple mechanical terms, like an empty gas tank. But as we're going to see, emerging science reveals a system that is breathtakingly elegant and, honestly, surprisingly complex. We are diving into the cutting-edge biology of weight management, and we're moving far beyond the stomach to discover how the rest of your body is actually pulling the strings. So get comfortable, focus in, and let's get ready to completely change how you understand your own biology.
Okay, let's dive right into this. Is your muscle controlling your hunger? Now, I know that sounds completely counterintuitive at first, right? Conventional wisdom has pretty much always told us that hunger is just the product of an empty stomach. You probably picture it as a super simple process. Your stomach empties out, it grumbles, and it tells your brain, hey, it's time to eat. But the research we're unpacking today introduces a completely different and frankly fascinating premise. It turns out that your muscle mass, and get this, even your skeletal structure, are actively communicating with your brain to regulate your appetite. Yeah, your muscles aren't just there to move you around. They are actively sending messages in this continuous, sophisticated dialogue with your nervous system.
Section 1. Enter the Gravitastat, the weight sensor. So, to truly grasp how incredible this is, we kind of need to reframe hunger entirely. Think of hunger as an unsolved case for your brain. Because remember, your brain is locked away in the dark vault of your skull. It doesn't have eyes looking down at your waistline to see how much you weigh. So it has to rely on biological informants, like the Gravitastat. This is a biological system where bone cells literally detect your body weight to signal the brain to eat less. Think of it like a biological bathroom scale. But instead of you stepping onto it just once a day, you've got these specialized cells within your bones, called osteocytes, acting as tiny mechanical sensors. As you stand, as you walk, these cells are constantly monitoring the physical load and the heavy lifting of your body in real time. It's wild.
So the crucial point is how this mechanism actually plays out to control your appetite. Basically, your leg bones act as this hidden control center, actively registering the downward force of your mass. And they don't just keep that info to themselves. Those signals travel all the way up your nervous system directly to the brain. If your leg bones feel the weight getting heavier, they send out an alert. Your brain gets the memo that the physical load is increasing, and it immediately dials back your urge to eat. It is a brilliant evolutionary adaptation designed to protect your body from carrying too much mass. It's a stunning feat of biological engineering, and it's happening with literally every step you take.
Section 2. The Sarcostat and Ghrelin, the muscle thermostat.
Okay, so if the bones are in charge of sensing when we're too heavy, what happens when we actually start losing mass, right? How does the body protect the crucial muscle we need to survive? Well, enter the Sarcostat. This is a system suggesting that losing muscle mass actually increases hunger-stimulating hormones. If the Gravitastat was our internal mechanical scale, you can think of the Sarcostat as an internal thermostat. But instead of measuring the temperature of the room, this thermostat is measuring your muscle mass. Its entire job is to directly dictate your drive to consume food, all based on the status of your muscles. And if you think about it historically, back during times of famine, preserving muscle meant preserving your ability to hunt and, well, survive, making this an incredibly powerful automatic defense mechanism.
And this brilliantly illustrates the chemical chain reaction at the heart of that defense mechanism. So, when the body experiences a loss of muscle mass, it triggers an immediate biological response. It causes a really sharp spike in hormones like ghrelin, which you might have heard is often dubbed the hunger hormone. That ghrelin just floods your system, crosses the blood-brain barrier, and then powerfully stimulates hunger. What we're doing here is connecting a very clinical biological term directly back to that visceral everyday feeling of hunger you experience. Literally, when your muscles shrink, your sarcostat flips on, the ghrelin surges, and you feel this overwhelming drive to eat so you can rebuild that lost tissue. Now, what's really interesting about this is how these two concepts are constantly working together. This is where the true elegance of human biology really shines. We're looking at two contrasting yet deeply interconnected systems. On one hand, the Gravitastat acts as a biological brake pedal. When those bone cells in your legs detect a heavy weight, boom, they signal the brain to eat less. On the other hand, the Sarcostat acts as the gas pedal. Losing muscle mass increases ghrelin, which forcefully stimulates hunger. So your brain is just constantly balancing these signals. The bones are saying, hey, we're heavy enough, while the muscles are yelling, we're shrinking, feed us. It means hunger is not just an empty stomach. It's the result of a profound, ongoing biological negotiation happening across your entire body. Which brings us to the end of our explainer today, and I really want to leave you with this final provocative thought. How does knowing your muscles and bones are actively negotiating with your brain change how you view your own body? Seriously, the next time you feel hungry, I want you to think beyond your stomach. Think about the silent conversations happening right now between your leg bones, your muscles, and your brain. You are a walking ecosystem of incredible, cutting-edge science.
I really hope this explainer sparked your curiosity and maybe helped you rethink your relationship with your own metabolism. Thanks so much for joining me as we unpacked the science of the sarcostat. Keep learning, keep questioning, and I'll see you in the next explainer.